Hello, everybody. Thank you so much for being here in person and online. And thanks for the introduction, Marlo. I'm excited to talk about the Lake Winnipeg Community-Based Monitoring Network. I was thinking back a little bit, and we've had AGM presentations with researchers talking about how they're using the data. We've had presentations about the economic benefits of the data, but I don't think we've ever had a full-on community-based monitoring presentation where we talk about why the program is important and the impact that it's having. So I'm excited to be the one to provide that for you this evening. I don't think for the folks in this room, I need to really explain what's at stake here. Lake Winnipeg matters deeply to all of us, and that's why we're here tonight. It also matters environmentally, culturally, and economically. But unfortunately, Lake Winnipeg is sick, and it's been experiencing an increase in the frequency and severity of potentially harmful algal blooms over the last few decades. Luckily, though, we know from decades of whole ecosystem science at the experimental lakes area that phosphorus is the cause of these algal blooms. And so if we can address the phosphorus loading entering the lake, then we can have an impact on these blooms. And the community-based monitoring network comes in because in order to reduce the phosphorus load entering the lake, we first need to understand where it's coming from in the watershed. So here's a map of the watershed. As you probably know, the watershed is huge. It spans 4 provinces, dips into 4 US states. And when we look at a map like this, the challenges facing the lake can seem insurmountable, especially as Manitobans who get to enjoy the lake because of our proximity. Worrying about what they're doing in Alberta or in North Dakota can make the challenge seem overwhelming and a little bit out of our control. And this often leads to interjurisdictional finger pointing and not a lot of productive action to actually improve the health of the lake. But the good news is that not all areas of this massive watershed are contributing the same amount of phosphorus. And so if we can identify areas that are contributing more phosphorus on average, we call those phosphorus hotspots, then we can begin to target our resources and remedial action to those hotspots to have an impact on the lake. And suddenly this big, overwhelming challenge becomes more like a laundry list of areas to address in order to reduce the phosphorus load. So here's another map of the watershed, broken down to the major drainage areas of the lake. And this is about the level of data that's shared in the State of Lake Winnipeg report, which is a joint report released by the provincial and federal government. And from this data, we have a really good understanding of the major sources of phosphorus to Lake Winnipeg. So for example, we know that together, the Red and Assiniboine rivers contribute about 70% of the total phosphorus load to Lake Winnipeg. And so this is an excellent place to start if we want to have an impact on the lake. But this is still a really big area with a lot of different land uses, climate, topography, soil types. And so ideally, we would have higher resolution data to more accurately identify those hotspots. And that's exactly what the Lake Winnipeg Community-Based Monitoring Network aims to do. It complements that provincially and federally collected data by sampling at many of the smaller tributaries within those larger drainage areas so that we can more accurately pinpoint those phosphorus hotspots for targeted action. So here's an example of data collected from one of our sites. This is Rose Isle Creek in southwestern Manitoba. And here on this chart, you can see the blue line is water flow and the black dots are phosphorus concentration. And this is both throughout the season. Now you can see here that during the spring snowmelt period, both the water flow and the phosphorus concentrations are peaking. And that's when the snowmelt is running off the land and into our waterways and bringing the bulk of the phosphorus load with it. So this is a really important time to collect samples if we want to accurately estimate the phosphorus load from a site. We can see later in the season, it goes down to baseline, and then there's a rain event in late June that again increases the phosphorus concentration and the water flow. So that's another important time to sample. And the benefit of the community-based monitoring network is that volunteers and partners live, work, or commute near their site. And so they can sample frequently during the spring runoff period and responsively to these rain events and runoff events later in the season. More centralized monitoring programs have traditionally taken samples at these smaller tributaries quarterly and based off of a calendar, not based off of flow. And so you can imagine when you sample quarterly and not in response to these short windows of runoff, that you could be drastically underestimating the phosphorus loading from sites. And so that's where having the volunteers and partners on the ground ready to collect those samples is a huge benefit. So as you might have gathered from the last slide, water flow is really important to our program. So whenever possible, we collect samples at Water Survey of Canada stations. So if you're ever going over a bridge in rural Manitoba and you see one of these little boxes with an antenna and a solar panel, that's a Water Survey of Canada station. And the benefits of sampling, there's two benefits of sampling at these sites. One of them is that we can monitor flow in real time online and mobilize the volunteers and partners to collect samples when a runoff event is occurring. And also, it allows us to calculate phosphorus loads in our data analysis. And so I promise there's just 2 slides of math here, but I'm going to be using these terms, so I want everyone to understand. So the phosphorus concentration, which comes from the water samples collected by volunteers and partners, can be multiplied by the water flow to give us the phosphorus load, which is the actual amount of phosphorus running by a sampling site in a given year. And another important piece of data for our program is the drainage area. And that allows us to take the phosphorus load, divide it by the drainage area to get the phosphorus export, which is the amount of phosphorus being contributed by an area of land in a year. So this is kind of like a yield in agriculture. And this allows us to compare drainage or to compare phosphorus exports across sites that have different drainage areas. So with that, here's a map of our phosphorus exports from the 2019 field season. Sites that are more red have higher phosphorus exports and are phosphorus hotspots. Sites that are more green have lower or even potentially negative phosphorus exports, which means they actually sequester phosphorus rather than contribute phosphorus. And some of the sites that we've identified as hotspots in 2019 are actually sites that we've consistently identified as hotspots since we began the program in 2016. So here you can see all of the maps since we began the program together. And the color's coming up a little odd, but the red is popping out, and that's what matters. So you can see, especially in the southeastern portion of the province, there are some areas that are consistently popping up as red, and those are our persistent phosphorus hotspots. And so we can say with confidence that that resources and remedial action should be targeted to those areas to have an impact. And a lot of these sites are actually in the Seine River watershed. One of them is the Manning Canal, which was one of our initial sites we started sampling in 2016. Now you'll notice 2018 looks a little bit different. I'm not just going to ignore it, but 2018 was a really dry year. And so there was low water flow across all of the sites. And we know that water flow is an important part of phosphorus loading from the equations that I showed earlier. And so there was just really low loads that we measured at all sites, and that resulted in low phosphorus exports in 2018. So it wasn't a great year to identify phosphorus hotspots, but we were able to use that data to demonstrate the importance of water flow in phosphorus loading. Now we have a lot of data that's almost ready to be shared. I wish it was ready for tonight, but because of the pandemic, we've had a little bit of a backlog of samples build up because of challenges accessing the lab and equipment. So one of those years of data is 2020 data. And you might recall, as Bruce mentioned, that was the year the pandemic came to Winnipeg, actually at the exact same time pretty much as the spring melt, which was extra stressful. But we are grateful that our science advisors adapted the protocols quickly, and so volunteers were able to continue to sample safely. And this was a year that a lot of other monitoring programs won't have data for, because they didn't have that nimble and responsive network of volunteers and partners on the ground ready to sample. Another unique year, but for different reasons, is the 2021 field season. So 2021, you might remember, was a really dry year in Manitoba. I think one of the driest years on record. And so that year we can expect really low loading from a lot of the sites, and for the phosphorus export map to look a lot more like the 2018 map. And then 2022 data is going to be probably the complete opposite of 2021 data. We saw extreme flooding and one of the wettest years on record in southern Manitoba. And so in 2022, we can expect to see high phosphorus loads from our sites because of the high runoff conditions caused by all of that snow that we got over that winter, and then those big rainstorms that just exacerbated the spring flooding. And the 2023 field season is now underway. We have 113 flow metered sites that we're sampling at, which is the most that we've ever collected samples from, and is quite exciting. And we plan to get back on track with sharing the data annually once the field season ends. We'll analyze the samples, analyze the data, and share it prior to the next field season so that it can be quickly incorporated into project planning. And I just wanted to share some preliminary data from these sites. So the Manning Canal watershed I mentioned, which is a phosphorus hotspot in the watershed, we do have some data available from 2020 to 2022. I snuck in some 2022 samples into the 2021 batch to get you guys a sneak peek. So you can see that it's kind of three very unique years. 2020, we saw relatively like medium phosphorus loading, I guess. The area of the Manning Canal contributed about 18 tons of phosphorus, and that resulted in an export of 0.38 kilograms of phosphorus per hectare per year. And then we can see 2021, where the export is more green. That means a lower phosphorus export, and that was the really dry year. So that's kind of what we were expecting. We saw 8 tons of phosphorus and an export of 0.06 kilograms of phosphorus per hectare per year. So that's quite low, especially for a phosphorus hotspot. And 2022, we can see those numbers just increase drastically from all of that water and flooding. So 72 tons of phosphorus contributed from that site, and resulting in a phosphorus export of 1.49 kilograms per hectare per year. So I think this site really depicts the differences that we're going to be seeing in these 3 years of data when we're ready to share it. And all of this data is coming out of a new lab partnership that we have with the University of Winnipeg, Dr. Nora Cassin's lab. Dr. Cassin's a Canada Research Chair in Environmental Influences on Water Quality. She was also the presenter last year at the AGM. And she's, what makes this partnership so great is that she also uses community-based monitoring data in her research. And so she is invested in the quality of the data that we're producing as well, just as much as we are. And another benefit to this partnership is that it frees up a lot of LWF staff time that used to be spent in the lab troubleshooting and all of that. We can now spend that time engaging more volunteers and partners and doing more intensive data analysis and ensuring that the data is being incorporated in management and policy decisions. So we're really excited to have this new partnership going forward. With that, I'm excited to talk about our plans for the next 5 years. So Alexis mentioned that we have a new strategic plan that we've developed, and this will guide our work over the next 5 years. And she mentioned goal 3, which is all about evidence. To me, this goal is all about the Lake Winnipeg Community-Based Monitoring Network, but I might be biased. And the goal states that we are trying to understand phosphorus sources within persistent phosphorus hotspots. And so it's all about taking our data to the next level. Right now, our data tells us where phosphorus is coming from. So we know where the phosphorus hotspots are located. But we don't know what makes those sites phosphorus hotspots or what's contributing to these high phosphorus loads. And so this is something that we're going to be working on understanding over the next 5 years. And one way we want to do that is by increasing our monitoring capacity and resolution within phosphorus hotspots. So, for example, I mentioned the Manning Canal in a previous slide as one of the persistent hotspots that we've identified through the program. And with this new strategic plan, we're going to be setting up additional flow metered sites upstream and downstream of the city of Steinbach, which is within the Manning Canal, to try to tease apart the rural and urban sources of phosphorus within that watershed. And that will help us to understand what is contributing to these higher phosphorus loads, and then give us a better idea of where to begin to remediate these high phosphorus loads. And down here, you can see a picture of our cool new instrument, a laser flow meter, which we'll be using to collect that flow data from these new sites. This work will also include combining the community-based monitoring data with other sources of data like land use data or livestock data from agricultural censuses to better understand what is correlated with these high phosphorus loads. What types of land use? Is it wastewater? Is it really high densities of livestock? These are some of the questions that we'll be able to answer over the next 5 years. Another way that we are targeting action to hotspots is through our partnerships with the watershed districts. And the watershed districts are key to this program in many ways. They help connect us with citizens to collect water samples, but they're also local decision makers in their watershed. And so they can use our data to target their projects, their on-the-ground projects like water retention projects and wetland restoration projects to hotspots in their region where it'll have the greatest impact. And another way that we are trying to address the phosphorus sources in the persistent phosphorus hotspots is by building partnerships to fill research gaps. So one example of this is through our partnership with Dr. Darshi Kumaragamage and Nora Kassin. Again, her name has been coming up a lot. They were doing a soil amendment and manure runoff study and used the community-based monitoring network data to pick their field sites within phosphorus hotspots. And so they ended up studying manure runoff within the Manning Canal watershed, which will now be a great source of data for us as we try to understand phosphorus sources within that watershed. That was a really big data gap for us previously. So we're excited to see what the runoff from these sites looks like and how we can incorporate it into our work going forward. But ultimately, this program was designed with government funders in mind. So before this program was developed, funding programs that were meant to improve the health of Lake Winnipeg ended up just kind of sprinkling the funding over the vast watershed evenly. And we thought with better data, they might be able to make more impactful decisions for the health of Lake Winnipeg and get more bang for their buck, phosphorus reduction wise. So with the community-based monitoring data, now we've been advocating the federal government, like Alexis mentioned, to target the Lake Winnipeg Basin Program funding to these phosphorus hotspots where it can have the greatest impact. Part of this advocacy included writing a policy brief called Realizing the Full Potential of Community-Based Monitoring. I think there's some of them on the table over there. And it talks about how community-based monitoring is important to supporting better regional decision-making And it actually goes into detail on how the government can implement the data in order to make more evidence-based decisions and see real phosphorus reduction impacts for Lake Winnipeg. And now that the federal budget came out, and it seems like the Lake Winnipeg Basin program is being renewed for potentially another 10 years, we're excited to work with the group at the Lake Winnipeg Basin program to incorporate our data in this next rendition of the program. And we actually have a meeting with the folks at the Lake Winnipeg Basin program on Friday to talk about this, which is exciting. Provincially, the provincial government recently had a call for submissions for their water strategy action plan, and the Lake Winnipeg Foundation put in a submission, of course, and made a strong recommendation that the government of Manitoba incorporates the Lake Winnipeg Community-Based Monitoring Network data into provincial decision-making processes. And so the water strategy action plan isn't released yet, but we'll be tracking that as it's released to see how they are incorporating the data into this new action plan for the province. Now, just to finish up, I wanted to highlight two of my colleagues. First of all, I want to highlight Claire Harvey, who's in the front here she's doing a lot of tech work tonight, but normally she's on the programs team and in the field doing sampling. Claire began with the Lake Winnipeg Foundation in January, and she's already led us through an entire seamless field prep. And I know it was seamless because of her amazing organization skills and tenacity to get through that intense period. So thanks, Claire, for all your work so far in a short amount of time. And then secondly, I would like to thank Carl Friesen-Hughes for his awesome work. Also pretending to be on the communications team tonight, but don't be confused, he's a programs team member. So Carl's the field and data technician. He began with LWF in November, and he's already systematized all of our data analysis, taking it out of these manual Excel spreadsheets and putting them into this R coding software, which completely automates the process, which is pretty cool. He's also the one leading the way with that laser flow meter, which is really exciting. And so I'm really excited about all the capacity that we have on our programs team right now, especially with all the work that we have to come over the next 5 years with our new strategic plan. And you may have noticed I didn't swallow a beach ball, but I am just going on maternity leave at the end of June. And I have full confidence in Claire and Carl taking this program forward. And I can't wait to follow along with what they do over the next year and also see all their fresh ideas and how they incorporate them into the program. So awesome work, Carl and Claire. And with that, if you're interested in the data, you can go to our website or to Lake Winnipeg data stream. And of course, you can always email me or anyone at LWF to get in touch.